Hello and welcome to this lesson about rate of change. The learning target for this video is to determine the rate of change from a graph and from a table. So let's talk about what rate of change is. Rate of change is something that you've probably already learned about, slope. And slope, let's do it this way, is equal to y2 minus y1 over x2 minus x1. Now, the difference here with rate of change is that we're looking at maybe something unconventional on the graph, or we're looking at real world data. And so in other words, it doesn't fit a nice little perfect line or anything like that. And so rate of change kind of is slope in word problems. It's just a really good way to think about it. Now, when it comes to figuring it out, there are two ways to do this. Two ways to do it. First way is you use that formula. You find some y's, you find some x's, and you crunch the numbers, which we can do. The other way, though, especially on a graph, is simply to do use what I like to call finger math, where you use your finger and you count the change and going up or down and then left or right. And so what you're looking at is you're going to write your answer as a ratio of how far you've gone up or down and how far you've gone left or right. But here's what we have to know. Sometimes you might have some funky looking graphs, okay? And so I'm going to draw a couple of them. Let's have one that looks like this. Goes up, goes up, goes up, goes up. Since it's increasing from left to right, your answer will be positive. But if we have a graph that looks more like this, where it's going down, 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 it's going to be negative. So you can still use the principles of finger math where you're like, okay, let's see how far up I've gone here, how far over I've gone there, but just know that your answer will be a positive fraction. Whereas if you do the same thing here, down and over, you're going to have a negative answer. And so let's look at some examples, and I think that will help us out a lot. So let's look at some from a graph. I think this is a great first example because it kind of leads us into a little bit of a warning, which is that we need to read the axes. And what I mean by that is we have to realize what's going on here. So if we kind of look at the scale, it looks like this is much longer from left to right. However, it's only going from 0 to 6. And here, it's actually going from 0 to 15. So be careful of that, because especially if we're talking about real world data, sometimes these things down here might be days of the week, it might be months, it might be years, and then in these numbers here, they could be a population in the thousands, they could be money, again, in the thousands or in the millions, or hundreds, depending on the situation. So make sure we read the axes and we kind of understand what it is we're dealing with here. And actually, to kind of make things a little bit easier, let's kind of plot some points. So let's say we'll call you A, and we'll call you B, and we'll call you C. Actually, wait, let me put my B right there. All right, so let's say we want to find the rate of change, which I'll just abbreviate ROC, from A to B. Well, the way it works, you can use finger math, and you can just, on a graph, go down and over. And since I'm going down, it's going in this general direction, my answer is going to be negative. Now I just have to count how far down I'm actually going. So I'm going down 1, 2, 3, 4. And then I have to figure out how far over I'm going here. Here's again where I have to look at my axes, and I'm going from 1 to 2, so it's only 1. All right, so you got to be careful. It won't count all of those because that's not actually how far over I'm going. That's what the graph looks like, but I'm only going from 1 to 2. So my rate of change from point A to point B is going to be negative 4. Let's see here. Let's now do another one. Let me clean up some space. Let's do the rate of change from A to C. Now, this is again why we're not really doing like slope, if you will. Because we're going to, this is not a straight line that doesn't follow a consistent slope. We will get there at some point in time. But what we're going to do is we're going to go from A to C. So I'm going from here to there. I can still use the premise of finger math. How far down am I going? How far over am I going? In this case, I'm going down 1. Or so first it's going to be negative. So I'm going to go down 1. But this time I'm going over 1, 2. Or so no, I'm not going down 1. I'm going down 2. My bad. Clarify that. There you go. All right, so we're going down 2, going from 12 to 10 on the y-axis, so that's what I'm looking at. And then I'm going over 2 spots, so 2, and then this becomes -1. Finally, I want to show you a rate of change. So it's the same color, I guess, rate of change, but this time from B to C. And so with B to C, I'm going up. And so that means that this is going to be a positive rate of change. And I'm still looking at a fraction of how far up I'm going versus how far over I'm going. And so I'm going up 2 spots, but I'm going over 1. So it's going to be 2 over 1, like that. And so these are some basic examples of working with a graph. But again, I can't stress this morning, read the axes. Make sure you understand what's going on. Just to kind of, for good practice, we'll do one more. So let's look at this graph. This graph, the axes are more normal, scaled out. So like how far this is matches up. Oh, actually it's not. I take that back. So again, we have to be mindful of that. But anyways, let's take a look at a couple of things. One thing I'd like to point out is that if we were to do the rate of change from D to E, it is 0. Because you're not going anywhere up or down. The ratio is 0 over 1, and so that's just equal to 0. Again, if we're going from B to C, we're going negative. And let's see here, so this looks like it's going by 5, so 5, or 2s, I should say. So 2, 4, 6, 8, 10, 12, and then over 1. So this would be negative 12 over 1. But again, this is how the graphs work. You just have to look at it. Sometimes you might jump points. So you could go from A to G, and so we're going over 7 units. Actually, let's do this in another color. A to G, so from A to G, our over is 7 units. It is going to be going down, so it is negative, but we're only going down 2. So the rate of change is 7. But again, you got to read the graph to be able to kind of understand what is the distinction on it. How much are you changing each time you count? Now, let's talk about some table examples. So with the table ones, we're going to have to do a little bit of math. We're going to have to apply the formula. Now, when I made my table in Desmos, I couldn't type in the months, so I had to write them in here. And this is kind of reminiscent of what you might actually see when you're doing some of these problems, because, again, rate of change is usually connected to some real-world applications. So let's say we want to find the rate of change from March to June. Well, to figure out that, we're still going to do this ratio of how far we've gone up or down versus how far we've gone left or right. Or I could also think of it as the formula of y2 minus y1 over x2 minus x1. And so let's see here. If I'm talking about March, talking about this number, or this point, and that point. And so for the y's, what I'll do is, and we even see it, x's and y's, I'll go with 58 minus 42. And then I have to go with March. And so March is, or we could think about it as, the months, and March is the 3rd month of the year. This is the 6th month of the year, so I could go 3 minus 6. If I wanted to, I could look at the table and say, this is the 2nd data point, that's the 5th data point, so I could easily say 2 minus 5. Either way, it's going to work out to be the same, because when I take the difference, or I count 1, 2, 3, it's going to be negative 3 here. And then I have to take a look at the numbers I have. So 58 minus 42 gives me 16. And I can't simplify that, so it would just be negative 16 over 3. And that's how you do a table. It's very similar to just finding a slope like maybe we did last year, or we'll do later this year looking at a graph, but you have to extract it from a table. So good luck with your homework or practice, and let me know if you have any questions.